the techniques and methods that empower individuals to control and measure and learn about their environment. And certainly, for a long time, we've been doing that, and the technologies that we use, the tools that we use, are personal tools. But somewhere along the way, things have spiraled massively out of control and gotten mega complex. And now I feel like we live in a world where there are a lot of technologies that we all use personally, like I drive a car, I've got an iPhone, I've got this laptop. I have no idea how most of those things work in a deep way, and I couldn't recreate them. I'm just a user of the technology, and that's okay. But if I wanted to build something that had an equivalent power or used an equivalent amount of knowledge that these things, these artifacts take to create, I wouldn't know how to do it. So in a sense, it feels like we've got all this technology out there and all this knowledge, but it's not really accessible to an individual. Like, I can't take advantage of the stack of knowledge and technologies that go into making an Apple laptop. Now, a whole company can, teams of engineers can, but I can't. So I started thinking about, well, what technologies do I actually know enough about to deploy to serve whatever interest I have? And in general, how do consumers do that? And in fact, how do makers do that? And what's sort of the difference between how individuals use technology and how experts, domain experts, use technologies? So, I guess I'd like to just try a quick exercise. I think it might help us see two different ways that individuals still innovate with technologies, and how technologies tend to, in some ways, transition from closed domains where it's difficult to access them. For instance, I don't know anything about building a car, I don't know anything about launching satellites, I don't know anything about mining oil, but there might be technologies in those industries that could help me as an individual build a new product, if only I knew how it worked. So I think it's interesting to think about how those kinds of technologies can flow from these sort of closed domains to individuals and consumers and makers and hobbyists alike. So I just want to try a quick experiment. Let's imagine we're all innovators here, and the goal is to, wait a second. I didn't start a timer, did you?
No.
Is anyone keeping, okay. I'll just give myself 14 minutes. So the goal here is to imagine that we've got, the whole world's full of different technologies. You all have different expertises. Can you solve this problem with just what you know? So you're not allowed to get an engineering team or spend more money or spend more time. Does the world and the level of human sophistication and technological sophistication, does it provide enough power to an individual to accomplish these two tasks by yourself? So what do you guys think? Is this first one doable? Get an aerial photo of your house from 500 feet. Yeah. And I'll just say that you're allowed to do as much research as you want before you start. You can order as much stuff as you want before you start. You just can't assemble anything or work on anything. So researching is allowed outside of that window. So what's the consensus?
Yes.
Mostly
Yep.
yes?
Yeah.
How do we do it? What would be one way? Build a drone? Just a drone?
Okay. Helium balloon and a phone.
And a phone. Okay, so balloon and a phone.
Or a kite.
Or a kite. Right. Okay. Exactly right. And so now none of you even needed to go down Google to kind of come up with those ideas. Like, how is it possible that we have such a kind of intuitive grasp of these different technologies, balloons, helium, phones, cameras, drones, that you can instantly in your head put together a solution that would probably work? I think that's interesting. Okay, because I have a feeling that the second question is less obvious for some reason, even though maybe it's not any less doable. So yeah, here are some of the ideas that I had. I actually didn't say phone for some reason.
Didn't make you all of them?
Yeah, they did. And so Grassroots Mapping is one of the groups that did it, and they put this really awesome DIY guide together about how to do that. And I think it's interesting. So I think this is an example of, you're a consumer, you're not a domain expert in any of those technologies, but because of the world we live in, there are all these consumer artifacts that are available at low price points really quickly that you can basically duct tape together and take advantage of their individual powers as independent tools and create a new tool for yourself. So it's kind of like, there's something interesting there. Although no one understands about how a lot of this stuff works, you can still kind of stitch it together to build new things. I think that's interesting. But what about the second one? Anyone have any ideas?
Manure problem.
Yeah.
I know a visual temperature sensor to see if you're showing any symptoms.
Yeah, so I don't know, right? So what we have to do is now go become domain experts, because apparently the culture, the common culture that we all share, that includes things that includes a knowledge about the common technologies that we have access to. There's not really a lot of coverage about how biotech works and what the verbs are that the tools do in biotech, right? So it's possible that there are non-molecular biology ways of diagnosing H1N1. There are influenza kits on Amazon, I checked, but they won't tell you if you've got H1N1, just influenza serotype A or B. But it's still pretty cool that there are like these tests on Amazon. So maybe you could, get someone to help you, an expert to help you for the price point. There is this Google group for DIY Bio that has some kind of smart people on it who want to help do DIY stuff, and they are domain experts, and they are interested in weird applications of the technology. So you could try asking them. Okay, so that's what I would do. But that's because I know a lot about biology. And so I think the second example is interesting because it can also be done under these constraints, but you need domain-specific knowledge. And I consider these two different examples, or these examples as kind of emblematic of two types of individual innovators. On this side, there's like a consumer innovator who just kind of duct tapes together stuff that they can find, that basically consumer artifacts that already exist. They don't need to understand or re-engineer. But they see, oh, hey, like I'm a kite surfer. I really want pictures of me doing tricks on my kiteboard. It's really hard to get cameras out there. But I see that drone and I see that GoPro. If we just stick them together, instant solution. And then there's actually a little niche market for that. Maybe they start a little company. But it's not really a big, amazing pathway to bringing a new technology to the world. But it's still cool. They're using technologies in a new way and getting some utility out of it. Now on the other side, this is more of like a, I call it sort of the hobbyist-driven innovation, and I think hobbyist is such a weird term. We could say hobbyist, maker, amateur, I don't care. But the thing is, most hobbyists are actually experts, and they're actually professionals in disguise. So computer revolution hobbyists, the Homebrew Computer Club is a good example. All the guys who were building the computers in their garages were doing it because they wanted to bring their work home, but they couldn't get time on the computers at work. And so they were scrambling around trying to figure out how to make their own computers so they could just mess with them. Not because they wanted to solve any practical problem. They wanted to do programming, and they wanted to see how far they could go. And so it's interesting that their motivation wasn't directly commercial in a lot of ways. Also interesting that because of their hobby and their deep domain knowledge in it, they sort of trailblazed a path for others to follow to get access to this technology in a cheaper way. And the kind of news coverage that followed them led to the establishment of, in a more general part of our culture, an understanding of what those technologies were and how they worked. So I see hobbyists as sometimes being a bridge that connects wider individuals who don't have a lot of domain experience in a particular area to technologies that are kind of exotic or kind of inaccessible to individuals. So, oh yeah, if you want to see, this is supposed to justify the H1N1 example. So here's a sub-$1,000 or less sub-$1,000 molecular biology lab with enough stuff probably to do it. So I haven't ever done it. I don't know if I want to even try, but it's reasonable to claim that it should be possible. So yeah, this is all I'm just trying to say. Hobbyists, innovators, motivated by the technology, they want to play with it. They've got deep domain expertise, and their work ends up trailblazing a path for other hobbyists to get involved in a technology sector that was otherwise opaque to them and not available for intuition or solving problems that they're trying to solve. So I don't know how else, as an individual, you gain a sense of intuition about what technology that exists right now that you don't know about could solve a problem that you have. I mean, you get those sorts of ideas by Googling around on Hackaday and internet and talking to people and going to meetups and stuff like that. It's really people, amateurs, and people who are playing with technology and pushing it in weird directions and talking about it that let you see the boundaries of the space that a technology provides access to. And so hyping hobbies are really important for that. And that's sort of my characterization of like consumers. So the main thing I wanted to say in this beginning part was just that I think hobbies are super important. They appropriate, remix, and refactor inaccessible, exotic technologies into forms that are sort of personal scale. They consumerize the technology. They don't actually want to necessarily make a huge business out of it, but inadvertently, by doing that, they may be laying the groundwork for someone else to build something on top of that platform that leads to a huge new application area. Who knows, right? So just my thoughts on how exotic, arcane, and non-practical technologies, because of hobbyists who love them, can sort of become more accessible to the public. And then when that happens, perhaps they get kind of rolled into some new product that actually disrupts the existing industry in a way that no one expected because they weren't thinking about this use case. So let's see. I got 5 minutes left. So I'll show you some DIY bio stuff. All right, so DIYbio.org, a almost nonprofit organization. We're almost there. So it's a small website, a blog, a mailing list. I'm very excited. Today we just relaunched our blog. We now have a professional blogger who's writing for us. And how many of you guys are on mailing lists that you don't actually read? Like everyone, right? Some people say they're not. I mean, so we've got a blogger now who reads our mailing list for us and for you, and then posts the important stuff on the blog. So you don't have to read the mailing list to keep track of what's going on. I'm excited about that. And we've got a big list of all the sort of local groups and labs around the world. So if you want to do DIY stuff or get help diagnosing yourself with H1N1, go here. And then I'm going to show you some tools and kind of commercial related projects that either sold something or raised some money or at least in some way seem kind of real. That's kind of related to DIY stuff. So best example, Kickstarter project. PCR is super instrumental in molecular biology, and it's what you would use to do the H1N1 thing. Normally costs like...
What is PCR?
PCR is a process for making a bunch of copies of a specific region of DNA. So it's like copy, or like control find.
Polymerase chain reaction.
Yeah, exactly. So the guy who did it, Josh Raffetto, he's working on a new PCR machine that's disrupting industry for called qPCR. And I won't go into the details, but normal PCR machines cost $2,000 to $5,000. qPCR costs $20,000 to $60,000 maybe, and it's just coming off patent. So kind of what's happening is people like me and him are attacking the equipment market with generics now that things are coming off patent. And we're doing it because there might be a business opportunity. There's definitely one for this, but also we want to see more people using these tools. And who's going to do it if we're not going to do it? So let's just do it. This just came up too. This just launched a couple days ago. This is sort of an interesting, there's a funny story behind it, but basically this company was going to make an open source personal PCR machine like the personal PCR, or open PCR, excuse me, and then their company failed. And a year later, they decided, well, we'll just release everything for free. So there's all these reference designs now for the prototypes that they made. They're not really designed for manufacturability, but it's cool. You can get all the source code and everything from their site. So another PCR machine that's free. This is a company that's selling gel boxes and PCR machines, reagents, pipettes and stuff. IO Rodeo, they're in California. They started as a consulting company for scientists who wanted to wanted weird stuff like this. I don't know what's on this page. This thing. It's a little immersive environment for a fly, and they put little neurons in the fly's brain to see how its flight system works while they manipulate the lights to make it think it's flying around. And so scientists, it's like a little bit out of the expertise range for a biologist to make that. So this company started to just do contract engineering, and along the way started making a bunch of cheap stuff, open source, and now they're selling a bunch of educational stuff to DIY. let's see, there's transilluminators, there's reagent companies, there's this do genetic engineering and synthetic biology in a kit that takes half an hour from an iGEM team company that just started. They're doing a good job. These guys make patch clamps that amplify neuronal pulses from insects, so you can actually hear neurons firing with this $100 kit. That's pretty cool. They've got a bunch of fun experiments that teach you about neuroscience. You all know about glowing plant, right? So big Kickstarter to make glowing plants, and no one's sure if they're going to deliver, and cast a pall across the name of DIY Bio and synthetic biology, or if they're going to do a great job and there'll be a bunch of copycats and everyone will be happy. I think they just got into Y Combinator, I'm not sure. So I've seen this thing glowing. It was really dim, but it did glow, so I think that it's not going to be a huge total disaster. At the same time that they launched a Kickstarter, I don't think they knew about it. This other company, Biopop, was selling these dino pets, which are just plastic shapes filled with algae that are glowing.